Hey everyone, just getting started with our spine series, and I wanted to start with our FK spine. I have for our setup today, just a set of joints. This time around, I decided to go a little bit tougher and start with 7 joints. I've got 3 controllers because that's usually what we work with: a root, a waist, and a chest. And we have 7 joints that we're going to work with. If you've done the FK arm setup, then you know that this is generally a pretty easy process. It's just about checking our rotation axes, which are, you can see over here. The currently it is the spine is working where it's aligned with the Z axis, but the X and the Y are not working really well. And if we select our root control and then go into our axis rotation, you'll see the control handles all match the world. So this is going to create a couple of problems, but they're not, unforeseen. So it's going to be actually pretty easy for us to figure these out and get them working. So step one, let's just start with a few basics. Let's make sure that we solve our basic problems first, which means let's bring in our spine joint 1 and attach it to our root FK. As always, I get rid of the shape node because I want to make sure that I can connect things really well and not have extra junk floating around. So let's just go and do this very easily, rotate to rotate, because it's rotate to rotate. And then let's test out whether the rotation works. So Z, well, that works. And if you remember, the Z rotation for the world and the joints was correct. But the Y and the Z, as you can tell, less good. So you can tell when I pull the X-axis, it twists, and when I pull the Y-axis, it rotates. So by default, if I wanted to look at how these guys are connected, what I would want to do is have X control Y and Y control X, right? Because whenever we grab the X-axis, this happens. Well, now it's like doing something slightly different, but at least the Y is now starting to work correctly. So what's going on with the X-axis is when I pull it forward, it goes backward, and when I push backward, it goes forward. So this is unintuitive, obviously. What it essentially means is that I need to make sure that when I move the X, it actually like reverses or inverts the numbers, which basically means that I need to use another node. And it's one of our like general mathematical nodes. And what I like to use instead of the reverse node, and I know that that would be where your brain would go first, but I don't use the reverse node because what the reverse node very specifically does is it takes a 0 and turns it to 1. And it's only after it goes between 0 and 1 that it actually starts to invert the numbers. However, with a multiply divide node, what I can actually do is I can take this and make this go to a -1. So it'll actually just multiply the 0 with -1 as well, which is always 0 as well, which means a 0 stays 1 and a 1 stays 0. Otherwise, if you use the reverse node, you'll get a funny little jitter and an offset, and it'll cause, well, quite a few issues. So let's just go over here, grab this X, drop it into input 1X, and then take the output X, drop it into the rotate Y. Let's do a quick test. Quick test. Here's this. Bloop, bloop. Yep. Oh, check that out. Ah, there we go. Okay. So this is step number 1. Let's name this. And we'll say FK joint invert. So that way, and we can also add like multiply or something, or MD. I try to do multiply divide so that I remember what type of node it is as well. You want to be able to identify these things pretty easily. So now that we've got these two, let's go to waist and So we've basically got what we need. Let's take a look and see if this is true. Do a quick rotate. Yes, the X, the Z, the Y. That's wonderful. Harder to see on the final one, but there we go. Of course, with the FK setup, there's always the element of parenting these things to each other. So select waste, select root, hit P, and now what you should have is a little hierarchy here so that if I rotate this, we have just what we need. Except I want to be able to do more than just what feels like a 3-joint setup, right? Like what I would like to do is be able to like curve very gently these joints in between so that when they rotate, they'll actually give us a little bit more sort of flexibility. Downside is it's going to change how we do this hierarchy, but that's okay. Let's first just bring in that nice tapered element for ourselves. So coming back over here, I'm actually going to clear this out and I'm going to start it from scratch because we don't actually need the control handles for this. What we need to taper is just joint to joint information. What does that mean? It means I need our first 3 joints, which means this one, and then I need to have it actually feed information to these 2, but like sort of in a limited way. I want it to reduce the amount of information it gives it so that if this is 100%, then this should be 2/3 or 66%, and this should be 33% of what the original is, because we're just assuming if this is 0 and this like if this is a full influence and if this is an influence of 0, then you'll just reduce the numbers as you go. Multiply divides, again, are best friends in this process. So once again, I hit tab, I hit Mult D, and I should be able to see multiply divide. And what I'll do is call this root FK taper MD. And I'll do like sort of a value number. So I'll do like a 0.6, and I'm not typing in the 0.6 in the name because obviously we don't want that, but we can also do this. So what I've basically done is I'm setting up sort of like a logic sort of thing where it's going to give a certain amount of tapering over here, and I'll make it taper by 0.6 and then or reduce by 0.6, and then I'll reduce this by 0.3. So what should happen, I'm multiplying this, sorry, I'm going to multiply these. So what should happen is I should get some really nice information basically for myself. So here's the rotate values. I'm going to drop them into input 1. I'm going to take the rotate values from here and do this. And I'm going to take the same rotate values, drop them into input 1. Remember, it's being multiplied by 0.3, and I'll take the output and drop it into rotate here. So here we've got these connections, and what you should be able to see, if this works the way I think it will, that's really nice. Look at that. Now you can of course increase or decrease the values of these things as you see fit. One of the things that I tend to make sure I do is I make sure that all of my joints are equidistant from each other, which means no matter where you click, how far down you go, there's always the same number on the translate X. Again, this is stuff that you should make sure that where you look at the joint setup thing, but that makes the calculation of such stuff really easy, because if there was only one joint between this and this, as in if this was a 5-joint chain, then I would just be tapering it by 50%, right? I'd be multiplying it by 0.5. But since I've got 2 joints in between, this is how I work. So once again, let me just do this one more time. I'll select this. What you should be able to see again is this. Look at that. And it's all going in the right direction, which is wonderful. So in theory, if I were to like take this and move this would look great, which it actually does. The only problem, of course, is our controllers are floating away. So this is actually a very easy fix. We do separate these from direct parenting, and we use groups to parent them instead, because that way we can actually like take information from other directions or other locales essentially, and not just this. So for example, I'm going to take this waste control and I'm going to group it to itself. I'm going to add in underscore group. I always name these things. I'm going to center its pivot so that if you notice here, it's actually sitting perfectly where it should. Here's this, group it to itself, copy, paste, underscore group. There we go. And also center this pivot. So now what I'm going to do is make it so that this group doesn't get information from here. It gets information from here. Okay, so that means this group is going to be controlled by this joint on only, we don't need it to scale or anything, but only for rotation and placement. And only, of course, that group. So I'm just going to go here and do a parent constraint. Make sure to maintain offset, otherwise this will break. And I'm going to do the same with this one. One up the way. Remember, we're trying to make sure that we don't mess up in our cycle hierarchies of where parenting and stuff goes, but just pretty simply to make sure that our spine works the way we want it to work. And we get very nice, smooth deformation. But there is just one minor unique thing that we have to remember, which is let's make sure that when we move our character, they're capable of moving, which means there's one more little control that we have to add in, or a little connection that we have to add in here, which is let's make sure this guy can move this guy as well. Now we could do a direct translate connection, except most of the times when you set up your character, their spine will not be on the 0, 0, 0, so you can't do the connection. What you can do, of course, is a simple point constraint. Don't do the parent constraint. You are going to mess it up if that's the case. If you want, you can maintain offset. There's no need for me right now. But you just want to make sure that you do a straightforward connection to make sure that when you move this around, because your character is going to hopefully be able to walk and relocate from the 0, that you're able to do this as well. All right.